Good morning to everyone. See, in the previous video, they discussed about the inverse of the sine, cosine and tangent function. The concept based on the problem should be completed. So now in this video, the cosecant functions, okay? Cosecant functions. The inverse of the cosecant function we will discuss, okay? What is the cosecant curve, okay? How to convert the cosecant curve to inverse of the cosecant curve, okay? That concept based on the problems we will discussed in this video, okay? So we know that, okay, what's the value of cosecant 0? Cosecant 0 is equal to the value of cosecant 0, okay? The value of cosecant 0, that is equal to undefined. Is clear? Same way pi, cosecant pi, okay? Cosecant pi is equal to undefined. Is clear? Same 2 pi, 3 pi, again minus pi, 4 pi, okay, minus pi. Therefore, in general term of cosecant n pi, okay, x is equal to n pi, again n belongs to z. The function is just not defined, the cosecant function. You know that previous class, okay, we are studying the previous class. Same way, again, I will choose the cosecant functions, okay. I will choose the cosecant function. Let the function f from, what's the domain? Domain R, but in the domain which value does not exist, n ez, okay. The value is equal to n pi, comma n belongs to ez. That is the integer value. That function should be does not exist, okay. Here to R by the cosecant by the f of x is equal to cosecant x, okay. F of x is equal to cosecant x. I will choose the function because of the cosecant function does not define the n pi value. That n pi means 0 pi, 2 pi, 3 pi, 4 pi up to n pi. Is clear? Same way n belongs to ez, okay, integers. So same concept, the given the function is, okay, cosecant function is not 1 and it is many one function. It is not onto function also. So but therefore the given function is, okay, what a conclusion, some same concept we could discuss, okay. I come to directly. So f of x is equal to cosecant x. Cosecant x is not a bijections, okay. Cosecant x is not a bijection function. So I will convert the bijection means I restrict the codomain and the domain also, okay. I restrict the codomain and the domain also. So you know that the curve, okay, cosecant x curve, just think about, say cosecant 0, okay, cosecant 0, again pi by 2, again pi. So the cosecant value does not exceed 0 pi, okay. The cosecant x does not exceed the 0 value, next pi, again what's the value, 2 pi, next minus pi, minus 2 pi. In this particular point the cosecant value does not exist. So I will just dot the green line, okay, just a dotted line to green line. Is clear? Now what's the value of cosecant pi by 2? The cosecant pi by 2, the value is equal to 1. Up here pi by 2, the cosecant value is equal to 1. Here y value is equal to 1. Up what's the point? Here pi by 2 comma 1. That particular point the curve should be here to here, okay, moving curve here to here, that curve. Is clear? Next same way, again 3 pi by 2. What's the value of cosecant 3 pi by 2? That is the value of minus 1. Up here that will minus 1, okay. Up here what's the value? 3 pi by 2 to minus 1. Up curve this go that paste, okay. This is going on. Let's go to real number. Same way cosecant minus pi by 2, the value is equal to minus 1 also. Up here minus pi by 2 to minus 1. The curve based on this below, okay, curve based on the below. Again the cosecant minus 3 pi by 2, minus 3 pi by 2 to the positive value, so you know that positive. Over here minus 3 pi by 2 comma 1, the value should be here to here, okay. And this is a cosecant function curve. Is clear? Cosecant function curve. Just now you see that all the values are cosecant functions. It's clear? Just to think about, okay, here up to what values, okay. Here what values are only for minus 1 to plus 1 only, okay. Above the minus 1 to plus 1, that is the meaning, okay. The cosecant curve does not exist minus 1 to plus 1, but minus 1 is including, okay, below the minus 1. Up I will restrict the domain, okay. I will restrict the domain, the entire curve real number except in the open interval of minus 1 to plus 1, because of the cosecant curve is minus 1 to minus 1 you will start. Again the plus 1 you will start. But in between minus 1, below the minus 1, again plus 1. The above, okay, the curve does not exist. Up here first I will restrict the codomain. Okay, therefore the range is equal to, what's in the range? The range of f is, the range of f is equal to, you can write the real number, okay, real number, open interval minus 1 to 1. Is clear? Minus 1 to, because of minus 1 is including. Is clear? About same the above concept I could return the form of, okay, that is the meaning minus infinity to minus 1 close interval union of here 1 to infinity. This is the concept. First I will restrict the codomain value. Next I will restrict same concept. Next I will restrict the domain value. Okay, so domain I will check it. So as usual, same way you will just will find out the domain value here minus pi by 2 to plus pi by 2. One, okay, domain that restricts the domain minus pi by 2 plus pi by 2. Next pi by 2 to 3 pi by 2, 3 pi by 2, again pi by 2. Same here minus 3 pi by 2 plus minus pi by 2. So restricts the, okay, different criteria of the domains. Okay, restrict the different criteria of the domains. But here domain I restrict the domain is, okay, I restrict the domain is the domain D. Okay, I restrict the domain is, what are the values are here, close interval, okay, minus 3 pi by 2 to minus pi by 2, but except value, what's the meaning? Minus pi. Again next minus pi by 2 to plus pi by 2. So I will come to directly the principal value based. So I will restrict the domain, okay, minus pi by 2 plus pi by 2. Okay, I restrict the domain minus pi by 2 plus pi by 2, but the 0 does not exist because of the 0 cosecant function is undefined. Up here I need in the domain is minus pi by 2 plus pi by 2 I will choose, but except what's the value? 0. Up here the domain is, okay, domain I will choose the domain is, okay, the domain is, what's the value? Close interval minus pi by 2 to plus pi by 2, but except what's the value? 0. And because of the cosecant curve does not exist the value of 0. Same, suppose I will choose the domain minus 3 pi by 2, okay, minus pi by 2 means the function, the pi value does not exist. Next pi by 2 to 3 pi by 2 I will choose means here value the pi does not exist, here minus pi does not exist. Is clear? Okay, so I will restrict the domain and codomain. About what are conclusions? The function f from, okay, the function f from, I will choose the domain, what's the value? Pi by 2 to minus pi by 2 to plus pi by 2, close interval, but except 0. Again that function, what's the range? Open interval minus infinity to close interval closed union of 1 to infinity is bijection. Is a bijections. Okay, is a bijections. So bijection means automatically the inverse function should be exist. Okay, what's the value? Here cosecant inverse of, okay, cosecant inverse, what's the domain value? Here minus infinity to open interval minus infinity close interval 1 minus 1, okay, minus 1, again the union of, okay, 1 to infinity. The restriction domain is close interval pi by 2 to minus pi by 2 to comma plus pi by 2, so except the value is equal to 0 is called the, okay, is called the principal value of branches. Is called the principal, okay, the principal value of inverse of the cosecant function. Inverse of the cosecant inverse of the cosecant function. Is clear? Okay, inverse of the cosecant function. Okay, by inverse of cosecant function, domain value is minus infinity to minus 1, the union of 1 to infinity. Okay, the range is equal to minus pi by 2 plus pi by 2, that is except minus value. This is a cosecant curve. So now I will convert the inverse of the cosecant curve. Okay, how to convert the inverse of the cosecant curve? Same way, just you will find it. Okay, first same way the cosecant curve here pi by 2 to 1. Okay, pi by 2 to 1. Over here that's the value is equal to x is equal to 1. Okay, the domain value x is equal to 1. Here 1 to pi by 2. Is clear? 1 to pi by 2. That value should be here to here. Is clear? Here to here. That's the first value. Okay. Next, again the curve. what's the value here? 3 pi by 2. Here plus positive 3 pi by 2 minus 1 value. But here 3 pi by 2, the value should be minus 1. What's the value here? Minus 1 to 3 pi by 2. So the curve based here. Okay, the curve based on the here positions. Similar case, again minus pi by 2 to minus 1. Here that point is equal to minus 1 to minus pi by 2. Here the curve based on the these positions. Curve based on the position minus 1 to minus pi by 2. But what are conclusions? Here, okay, that's the 2 point. What are the conclusions? So the principal value is equal to, what's the value? Minus pi by 2 to plus pi by 2. Here, minus pi by 2 to plus pi by 2. But what are conclusion? The maximum value of cosecant inverse is equal to pi by 2. At the points equal to x equal to 1. Next, the minimum value of cosecant inverse equal to minus pi by 2 at the points equal to minus 1. So note again the first another point, the maximum value of, okay, the maximum value of, okay, the maximum value of cosecant inverse, okay, just a little bit, the maximum value of, what are the conclusions? The inverse function, I will conclusion, the first one, the maximum value of, okay, the maximum value of cosecant inverse. Cosecant inverse is, the maximum value of cosecant inverse is pi by 2 at the points x is equal to 1. Same way, the minimum value, okay, the minimum value of cosecant inverse, the minimum value of cosecant inverse is minus pi by 2 at the points x is equal to minus 1. At the point x is equal to minus 1. Okay, this is the principal value, again the maximum value, maximum and the minimum value. These are 3 important conclusion points. Okay, so this is the inverse of the cosecant function concept. So next video you can watch the above concept based on the problems. Thank you.